Today we are going to take about HCF, highest common factor. Okay, so highest common factor, and by using Euclid's division algorithm. Okay, so Euclid's division algorithm to find out that HCF value. Okay, so now we move that the definition of Euclid's division algorithm. Okay, so what is the definition? And given positive integers a and b, there exist unique integers q and r satisfying a equal to b q plus r. 0 lies less than or equal to or less than b. So 0 can be accepted and b cannot be accepted. Okay, that is the definition. So given positive integers, so a and b are two positive integers, there exists a unique integer. This is quotient. Okay, so this is quotient. This is quotient, and r is remainder. Okay, so r is remainder. So that is the definition. Okay, are you understand this? A and b are any two integer and b is divider. Okay, so that is the positive integer, so d is divider. Okay, and a is any integers, any positive integers. Okay, so that is the definition. Okay, right, so let us move the procedure of Euclideans division algorithm. Okay, so the first step 1, to find out that HCF of two positive integers, say c and d, with c greater than d, follows the steps below. So two positive integers are given, which is maximum. Okay, so first you have to find out that which is maximum numbers, that only you have to take on left hand side. Okay, so applying Euclid's division lemma to c and d, so we find the whole numbers q and r such that c equal to dq plus r. So this form you will convert c and d on this form. Okay, but 0 less than or equal to or less than d, only we have to satisfying this condition. Next, step 2. Step 2, what is given? If r equal to 0, d is the HCF of c and d. So c and d is the given numbers. So the remainder will becomes 0. That is the number is d. That means d is the what? Divisor. That the divisor is the HCF of the given number. Okay, suppose r not equal to 0, that means the remainder becomes number applying the division lemma to d and r. That you have to taking divisor and remainder. Again you will take divisor and remainder again to find out that step 1. Okay, using step 1. So continue the procedure till the remainder is 0. The divisor at this stage will be required HCF. Okay, so first you will understand two numbers are given to identify which number is maximum. Okay, so which number is maximum, that the number you have to written left hand side. Okay, so next procedure, you will convert these two numbers. You will convert these two numbers is of the form c equal to dq plus r. Okay, where r is lies between 0 less than or equal to r less than d. Okay, so if r equal to 0, d is the HCF of c and d. R means the remainder. Remainder becomes 0. Divisor is the HCF of c and d. Suppose the remainder not become 0 applying the division lemma to D and R. Again step 1 you will do that. So continue this procedure till the remainder is 0, the procedure will be stopped. Okay, so now we'll move that the questions. Okay, so use division algorithm, Euclide's division algorithm to find the HCF of 135 and 225. That is the question. Okay. Okay, so these two numbers are 135 and 225. Which number is maximum? This is. So this is Z, this is C, this is D. So I will write solution. Okay, so which number is maximum? 225 greater than 135. So this is C greater than D. Okay, that means I will write is of the form by using step 1. Step 1, what is given? That applying Euclid's division algorithm to C and D, so that the number, so we find that the whole number Q and R such that C equal to DQ plus R. It is very easily to find out this. 225 I will divide 135. 135 is a whole number. That number contains only one time at 225. So 135s are 35. The remainder is what? 5. The remove 550. Subtracting this 2, 3 means 9 and 10 is 0. So that means 90. Okay, so that is the question. This is the remainder. Okay, so you will multiply it. 225 is equivalent to 135 into only one times. Okay, so only one times. This is quotient. Okay, so only one times plus and 90. Okay, so I will this is the form of C equivalent to, okay, DQ plus R. That means quotient, divisor into quotient plus remainder. Divisor is what? 135. So the remainder not become 0. Okay, the remainder not become 0. You will take again D and R. Okay, D and R. So D is what? 135 is equivalent to R is what? 90. Okay, so R is 90 into how many times 90 contains in 135? Only one times. So that means 1 into 90s are 90 plus the remaining is 45. Okay, the same procedure will do that. The same procedure will be followed as this also. I will write 135. Okay, so 135 90. So only one times 90. So the remaining terms is 45. Okay, so that also we had. So again the remainder is not become 0. So again the following taken, D 90 is equivalent to again remainder 45. 45 how many times are, how many 45s contains in 90? 2 times. Okay, so plus the remainder becomes 0. Are you understand this? So 90 is the divisor. You have to taking only divisor and remainder only we have to taken, and quotient will be removed. Okay, from the next step. Okay, so 90 is equivalent to 45 into 2 plus the remainder becomes 0. The remainder becomes 0, the procedure will be stopped. Okay, so what is the divisors on this term? What is the divisors on this term? 45. Okay, so 45 is the divisors. Okay, so 45 is the divisors. So 45 is the divisor. Okay, so the HCF of given number. What is the HCF of given number? 135 to 225. Okay, the HCF of 135 and 225 is what? What is the answer? 45. Okay, so HCF of 135 and 225 is 45 is answer. Simply you have to written for this step HCF 135 comma 225 is equivalent to 45. Simply you have to written for this step. So it is enough. Okay, so by using a Euclideans division algorithm to find out that HCF value is very easily to find out that. Okay students, thank you. இந்த சேனல் உங்களுக்கு பிடிச்சிருந்துச்சுன்னா சப்ஸ்கிரைப் பண்ணுங்கள், பெல் ஐக்கானை கிளிக் பண்ணிக்கோங்க. பிடிச்சிருந்தா லைக் பண்ணுங்கள், கமெண்ட் பண்ணுங்கள், ஷேர் பண்ணுங்கள். தேங்க்யூ காய்ஸ்.